everybody. I'm Kevin Speech, electrical systems engineer here at A&A. I've been on the R&D team for about 2 years now, working on our energy storage systems and hybrid energy system products. I did start my career off at UL, working on industrial control equipment and electrical power drives. And today I'm going to be talking about UL9540 and hybrid energy systems. Today we'll talk about what UL is. We'll go through a little bit about that, and then we'll talk about what 9540 is and how it relates to 9540A. At the end, towards the end, I'm going to touch upon on some different battery chemistries and their pros and cons. So what is a hybrid energy system? Hybrid energy system combines two or more energy sources to provide reliable, efficient output power. This could be anything from batteries, which would be your energy storage portions, to a diesel generator or a grid-tied product, which would be your AC input power. This can also incorporate things such as renewables like solar, wind, even hydroelectric power. So this is an ESS overview. This is ANA's EBOS product here. This highlights the major components of an ESS or energy storage system. So you have your inverters, obviously, control panel and control screen. Then you do have your battery packs as well as your battery management system, which is pretty much the backbone of your battery product. This controls things like charge discharge rate, voltage levels and monitoring, pretty much everything related to the battery. This is going to be the backbone of that. Now, this is a hybrid energy system. So as you notice here, we do now combine with a diesel generator, which is on the right-hand side. Um, same energy storage product here. The battery packs now sit below. But now, as you can see, there's a difference between energy storage and hybrid energy, where now we combine the AC input power of a diesel generator. So what is UL? Formerly Underwriters Laboratories. They did a bit of a rebrand in the last couple of years. They are now known as UL Solutions, but they are the global leader in safety and TIC, which is testing, inspections, and certification. They are also the global leader for standard development. They are in global markets and emerging industries and products. They are the front runners of creating standards and making sure that those become an industry benchmark for safety. Legal history, founded in 1894 in Chicago, Illinois. The main focus of UL when it started out was fire safety. Back in the 1800s, fire was a major concern as electrification was starting to happen in the US. The first standard they developed actually was for ironclad fire doors. Then in 1906, about 12 years later, they started their actual UL labeling service that we now know today as the UL sticker. So UL importance, obviously UL as well as other certification bodies in the industry. It's a safety benchmark for both quality assurance and safety assurance. It's the basis for other safety bodies such as NFPA and AHJs to base their safety standards off of. So departments like the National Fire Protection Association as well as AHJs, this could be citywide or statewide. They use UL to kind of base their own product quality standards on for safety. I want to touch about this briefly. Some of you may know, some of you may not, but UL recognition versus a listing. For recognition, there is a difference between recognition and listing. For recognitions, you do want to think single components. This is smaller scale stuff. So stuff like relays, fuses, controllers, electrical equipment that would incorporate into a larger system, that's going to get a recognition report. 9540 is a system level integrated standard, so it will obtain a listing report. So there is a difference between those two. So what is 9540? Certification standard for energy storage and equipment. The current revision is of March 7th, and this is the third edition. This was as of 2025. It's a system level safety standard. It evaluates the safety of the entire energy storage system, not just batteries or the battery pack. This covers all performance metrics such as electrical, mechanical, thermal, and obviously fire propagation. This has become the industry benchmark for energy storage products. It's widely adopted by both the National Fire Protection Association and authorities having jurisdictions, or NFPA and AHJs. Here I wanted to touch on a few dangers of thermal runaway. So these are recent battery fires that have happened in the last 2 years. They all kind of highlight their own dangers and issues. So the first one here, this one was personal injury. A lithium-ion battery exploded, and two firefighters were injured in the process. So that highlights the importance of safety and quality processes like 9540 to avoid personal injury. A few of the other ones, like San Diego in May 15th, this one burned for 17 days. So it's not just personal injury you have to worry about, it's ecological and environmental impacts. Obviously, batteries release toxic gases into the air, such as hydrogen. This could get into the ecosystem and the water stream and potentially affect persons or obviously the wildlife. The most recent one, Monterey County, California, this was in January of this year. This was a lithium ion battery plant, so they manufactured the batteries there. Fire burned for about 3 days, but this one, 1,200 individuals had to evacuate the area, so this took people out of their homes. Um, the issue with this one was the batteries were too closely packed together. So obviously one caught fire due to improper storage systems or storage techniques, and the fire propagated to other batteries, and eventually there you have thermal runaway. Um, this one I was reading up on. This one actually did release several large amounts of toxic gases into the environment. So this one did get into the water stream. This one could have lasting effects for not only months, but even years due to a battery fire. So, okay, now these are the major system level component requirements of 9540. These are the recognized components that I was mentioning earlier, as well as a few other requirements, but I'm going to touch on several of these right now. So, your inverters must be UL1741. Currently, there's no other recognized inverter standard in 9540. So whether it's AC to DC, DC to DC, DC to AC, it doesn't matter. Your inverters must be UL1741. The batteries in the BMS must be 1973. So you may have cell level 1973 certification, but if you put that into a module or a battery pack, for example, let's say 40S or 40S2P, it doesn't matter. Once you take that cell and incorporate it into your own battery pack, that new configuration must now be evaluated to 1973. And that BMS that you're using must be evaluated in that configuration as well. So, something to think about. You may think you're in the clear with 1973 cell level certification, but that's not always the case. Spacings. So this could be any kind of current carrying conductor, whether it's high or low voltage differences, or it could be your current carrying conductor and chassis or ground. You do need to meet table 13.1 spacings for these, so that table is going to be your best friend for this. Typically, if you have 1 inch between across the board, you should be okay. But again, this is going to be a case by case basis for your application or product. So battery management system, this does require functional safety. There's a few different routes you can go. 60730-1, that's a UL standard, or you could go IEC or even ISO standards for compliance for this. But functional safety relates to the software of your product. So how does your software handle certain critical faults or damage or other issues that could go wrong? This is the software's response for safety purposes. 9540 testing. So these are the basic electrical testing that you will have to evaluate to. These are typically across the board in most electrical standards. It's routine stuff like temp test, dielectric or high pot, EMC compatibility, and environmental tests for especially for outdoor rated products. You could be susceptible to a rain test or impact or rigidity testing. This is enclosure testing to meet your outdoor requirements. UL9540A, this is a fire propagation test standard. I'm going to skip over this one for now. I will come back to it. I have slides later on, but that is a fire propagation test standard that you must meet for 9540 requirements. Diesel generator. So if you have a chemical or a thermal energy storage system, and those definitions you can find in the standard itself, but those two types of ESSs you must meet UL 2200 if you incorporate a diesel generator into the system. Um, So yeah, I would definitely look out for that if you have a chemical or a thermal ESS. And then recognize components on all critical components. So this is kind of what I touched on earlier. These are going to be breakers, fuses, terminal blocks, your controller. Every component of your system is going to have to be a recognized component if it's deemed a critical component. So as you evaluate your system with your engineer at UL or Intertech, whatever that certification body may be, they will come up with a list of critical components that you will have to have component level certification on. So additional challenges. These are additional challenges that are not related to component level requirements in 9540. These are personal things that I've seen here at ANA that have been challenging to comply with. But manual updates, your manual most likely from the start of your project to the end will have to be updated. There are several additional requirements related to safety and install instructions that you have to incorporate there that you may not think of originally. Same with markings and labels. This could be additional safety labels, such as arc flash warning. Your ratings plate could require updates. There's probably 15 or 16 items you must incorporate on there, short circuit rating, available power, etc. Arc flash analysis. Now, this is going to be a two-stage analysis. It's going to include both PPE level requirements for servicing the product, as well as a boundary diagram for untrained personnel and install. So, arc flash is required. DFMEA, design failure mode and effects analysis. So, this is a fancy analysis that basically says if a fault were to occur, what happens, right? So, it'll go through what kind of injuries can happen, what kind of damage to the equipment can happen, and both its severity as well. So, based on your severity level, you may need to tweak the design a little bit. There are third parties that can come in and do a DFMEA for you, but yeah, this is going to be a required piece of the standard. So what is 9540A? This is the one I brushed over earlier. So 9540A is a test method for fire propagation, and it's not a certification standard. You cannot obtain certification to 9540A. This is required for 9540. This testing you must undergo this testing on your battery system. Um, this testing it determines system level install instructions such as spacings, whether it's unit to unit, energy storage system to energy storage system, or it could be the unit and a building or wall or some other form of enclosure. Four levels of testing are listed out in this 9540A. So it is cell, module, unit, and install level. And I'm going to touch on these on the next slide. So this slide shows 9540A flow testing ladder. So this relates back to the four levels of testing that I mentioned previously. You do start with your cell level test. So your certification body, your testing lab is going to do everything they can to induce thermal runaway at your cell level, right? Whether this is a high ambient test, 60, 70 C oven. This could be a piercing test. It could be an overcharge or undercharge test. Whatever it is, they will try to induce thermal runaway. If you're somehow able to pass at the cell level, meaning you do not have thermal runaway, cannot be induced, and your cell does not vent any uh, flammable gas or toxic gas such as hydrogen, you do not need to move on to the next level. So you would be able to stop there. Your 9540A testing would be deemed acceptable. This is rarely the case, as you cannot incorporate uh, fire suppression methods into cell or module level products very easily. This typically happens at the unit level, where you're able to have active fire suppression in case of a fire. You're also able to have containment of the fire, what if it were to occur, whether this could be a really thick steel enclosure or whatever. But at the unit level is typically where people do stop. This is going to be your battery pack level for fire testing. So challenges of 9540A now. Thermal runaway must be induced. Like I said, they're going to try everything they can to get your cell or your pack to fire propagate. This as of right now, the standard is written. You must do everything you can to get it into thermal runaway. The testing methodology. This is something to consider. So if you use a high ambient test, let's say 70C for your cell level testing, you must induce the thermal runaway in the exact same format as you move on the ladder. So module level, unit level, you will have to induce thermal runaway at that same testing specification, right? So you will have to test that 70 C ambient again. Fire propagation reduction methods. Again, you based on your fire propagation testing, you may need to incorporate additional fire propagation reduction methods such as fire suppression, whether it's a foam or some other kind of cooling, whether it's changing your enclosure to contain the fire, or you may even need to change your battery chemistry in general. So battery chemistries and thermal runaway. So this is a chart here that shows a lot of the common chemistries used in the industry today. So we have LTO, LFP, NMC, and even lead acid. They all have their pros and cons. They all have their thermal runaway tolerance levels are different, but there are obviously use cases for every one of these chemistries. So I'm going to go into a couple of them in a little more detail. So NMC. NMC is one of the most energy dense chemistries available right now. It is not that expensive, but there are trade-offs, right? So it's very energy dense and it can deliver a lot of power quickly, but the cycle life of an NMC battery is very low. So typically 1,000 to 3,000 cycles, depending on your ambient environment and depending on your C rates that you charge and discharge at. It is not as safe as other chemistries. Thermal runaway can be induced very easily with NMC. So for energy storage, this may not be the best route to take. But like I said, very energy dense and very cost effective. So LFP, lithium iron phosphate, this is another pretty energy dense chemistry, pretty cost effective compared to other chemistries, much better cycle life compared to NMC, typically 4,000 or more, depending on ideal operating conditions. Higher operating temperature and typically a 1C continuous rating. You can get all the way up to probably 4 or 5C intermittently for short bursts of time. Lower energy density than NMC, but still not bad. Typical use cases for LFP are energy storage systems as well as EVs, electric vehicles. They're also used as UPS or backup systems for both the medical and the telecom industry. Sodium ion is a new up and coming chemistry in the industry. It's a pretty good cycle life, 5 to 7,000. They do have a really wide operating temp range, anywhere from -20 to 60 C. Moderate discharge and charge rates, typically 2C, but you can intermittently do 4 to 5C, very similar to LFP. It's a very safe chemistry. So, very the inherent chemistry nature, the nature of the chemistry, you cannot induce thermal runaway at all. It won't catch fire. However, it does off vent flammable gases or toxic gamma gases. So there is a risk with Na plus, as is every other battery. But typical use cases, it is up and coming, but as of right now, it is used for backup or UPS systems, as well as it's starting to replace 12-volt batteries that you would see in, let's say, a generator or a golf cart. It's starting to replace those lead acid batteries for now. So now we're at LTO. So this is what ANA uses personally, this lithium titanium oxide. They do have a very high cycle life, 10,000 to 20,000, could even go farther, but it just depends on the environment, right? But very high temperature range, -30 to 65 C, and high continuous C rates. So 3C and above, it can handle pretty continuously. It's a very safe battery chemistry. It's very difficult to induce thermal runaway on an LTO battery or module. You usually have to try multiple different levels of failure to get LTO to set off. LTO is an excellent choice for hybrid energy systems, um, increased battery life, and it's very energy efficient. But one trade-off is that it is a little more expensive than your, let's say, LFP battery. So lastly, I want to touch on battery capacity. So, is a bigger battery better? And it turns out for hybrid energy applications, it's not. A more efficient, longer lasting, and faster charging battery is the better solution here. So like with LFP and NMC, you have more storage and you can fit it into a smaller, form and form fit frame. However, they do charge much slower and discharge much slower. So If you have your hybrid energy system and you want to rely on that battery for more output power and increased efficiency, once it's time to charge up, you're going to charge at a much slower rate as you would say LTO. So your efficiency is going to drop dramatically. LTO is optimized for hybrids. It will charge very quickly, and then obviously 10,000 to 20,000 cycles, your maintenance intervals are going to go down dramatically with LTO as well. So once you pass all your 9540 testing, once you pass all your 9540A testing, your fire propagation testing, everything is well and complies. You will have regulatory safety checks following this, and this will most likely be in the form of manufacturing site visits. This is probably a quarterly visit, but they will check things such as your critical components, that those are still being used and still match up to the report, and that the component is still being built and manufactured in the same way that was specified during the eval, right? You could also have a on-site installed inspection visit just to make sure that you're conforming to your install instructions and that nothing has changed there. You also need to comply to updated standard requirements. This is an evolving industry, it's an evolving technology, so the standard is going to change over the next few years to incorporate other battery chemistries and other regulatory safety checks. You will have a grace period, right? So if a new standard revision comes out on October 1st, you don't need to comply by October 2nd. It's typically about a year time frame that you would have to comply and update your product. But again, working with your certification body engineer would be the best way forward there. So thanks guys for watching. That wraps it up for my presentation. If you'd like to learn more about eBOS, you can contact me directly or reach out to our ANA sales team. And obviously there's tons of useful information on our website, anacorp.com.
All right, thank you, Kevin. So now if anybody has any questions, feel free to use the chat or the Q&A, or if you want to raise your hand, I can turn on your microphone.
One thing while we're waiting for Q&A to come in, one thing I do want to touch on quick is transportation for hybrid energy and energy storage. There's a few extra requirements there just for transporting batteries in general. You do need UN 38.3 on your batteries. That is a transportation certification. And then you also will need a PSDS or product safety data sheet, which all of your truck drivers or logistics team will have to carry that with them. And then the DOT is going to be your best friend for that as well. The DOT has a shipping guide for lithium ion, and most energy storage systems should fall under class 7 or class 10, but yeah, it's going to be application specific. So
All right, anybody have any questions for Kevin? All right, it looks like we have one.
What is the typical time frame for this complete certification process?
I'm sorry, could you repeat that? My speaker's a little low.
Uh, Time frame for certification process.
Gotcha. Yeah, I mean, that's going to depend on the certification body that you use. From my experience, the typical testing queue log is probably anywhere from a month to 3 months. But it also kind of depends on your design, how accurate and how up to par it is. But I would say probably 3 to 6 months. It's a relatively involved standard, and there's quite a bit of testing required for this one as opposed to some of the other electrical standards.
Are there any additional requirements as a combination? A generator, UL 2200 generator plus 9540 battery? Are there any additional apart from 1741?
Yeah, so you'll most likely have to repeat your 9540A testing in that configuration. So just be, obviously diesel fuel is flammable, right? So just adding that extra configuration, that revision of layout, you're probably going to have to redo some of your testing if you want to include that hybrid portion within your 9540 cert. 2200 would be its own testing standard and project, so that wouldn't be a part of anything 9540 related.
Understood. Thank you.
Right. Question in the Q&A. In NMC, if you have higher levels of MC, you reduce thermal runaway, you can have a 2.9 C rate for faster charge and discharge.
Gotcha. Yeah. I don't have a lot of personal experience with NMC, but yeah, that's going to be application specific, right? So yeah, I think in any application you can push any of these chemistries to a higher C rate for a X amount of time, right? So
All right. Do mobile generators need UL220 in mobile applications?
um so right now I think 2200 is stationary generator specific and standby applications. But I'm pretty sure mobile generators are kind of becoming more of a thing in recent years, so they're kind of working their way into requirements. So here at ANA, we obviously have mobile generators. We are seeing more requirements start to pop up, whether it's in the NEC or NFPA. There are becoming more and more applications or requirements for mobile generators, not just stationary. So yeah, if it's not in there yet, I would anticipate it would be in there pretty soon in the next year or two.
Um, will LTO run out of battery if the load is high and the generator can't keep up to charge?
Yeah, I mean that's the same as every battery, right? Well, if you're not able to charge, you'll eventually run out of capacity to sustain your load, right? So, um, obviously the higher the load, the quicker it'll discharge. But yeah, it's not just LTO specific. That's going to be any battery.
Okay, we've got one more in the chat and then I'll let you talk. Does your system have pass through to the load?
Yeah, we do have kind of pass through applications. It's not a standard feature, but we are able to for certain applications we do have that as a added feature. Yeah.
What is the typical mitigation um, types followed for unit level uh, thermal runaway mitigation?
Communication types.
No. Uh, what types of fire suppression are used at unit level for stopping thermal runaway?
Yeah, so the most common ones are going to be fire suppression systems. So they have canisters that'll set off. They'll allow the escape of foam based on thermocouple measurements. If that reaches too high, oh gosh, I don't know, 200C or whatever that set point is that you guys decide, that'll release the foam and it'll suppress the fire. Containment is another good way to go. If you have a thick enough steel enclosure with no kind of plastic exterior facing parts, you should be able to contain that fire pretty well at the unit level. But yeah, I would say those are the main two. And then obviously using safe chemistries, um, is a good route. So
Thanks.
yeah.
Any other questions this afternoon? All right, it doesn't look like we have any questions.